warm welcome at JT Classes. This side Kansas Sony and alumnus of NIT Calicut. Okay, what if I'll tell you that the entire quadratic equation chapter can fit into a page? Sounds interesting? Okay, so let's turn the entire chapter into a picture. In the quadratic equation, we know that equation is ax square plus bx plus c equal to 0, where a is non-zero. We know that if the equation's roots are alpha and beta, then sum of the roots will be alpha plus beta minus b by a, and product of the roots will be c by a. Now difference of the roots, so mod alpha minus beta, it will be root d by mod a, where d is the discriminant and a is the leading coefficient. Okay, x values we can also find by the quadratic formula, which is x equal to minus b plus minus root b square minus 4ac by 2a. Okay, and if we know the sum and product of the roots, then we can write down the equation also, which is x square minus sum of the roots into x plus product of the roots equal to 0. And we also know that the root satisfies its equation. Okay, so in the quadratic equation, the first topic, relation between roots and coefficient. After that, we do have the next, that is nature of roots. Nature of roots means roots will be real, imaginary, like that. So that we decide based on the discriminant d. If my discriminant is greater than 0, then we have real and distinct roots. If my d is equal to 0, we say that we have real and equal roots. If the d is less than 0, then we say that we do have the imaginary roots, and we can say no real roots. Okay, whenever d is equal to 0, then the equation will be a complete square. Okay, after nature of roots, it comes transformation of equation. Transformation of equation means, suppose I'll give you the quadratic equation ax square plus bx plus c equal to 0, and I'll say alpha and beta are the roots. Now you have to tell me a new equation whose roots are 2 alpha and 2 beta. So how will we do it? I'll just equate 2 alpha equal to x, and from here we'll get alpha equal to x by 2. So now in the equation we'll just replace x by 2, and after this replacement, whatever equation we'll get, that roots will be 2 alpha and 2 beta. Okay, this transformation we can do only if my roots are changing symmetrically, like 2 alpha 2 beta, 1 by alpha 1 by beta, alpha plus 2 and beta plus 2, alpha minus 2 beta minus 2, like that. Okay, suppose if the roots are I'll say the new roots are 2 alpha and beta plus 2, then we can't apply this transformation of equation. Okay, after transformation of equation, the next thing is symmetrical roots. Okay, symmetrical roots means we have the equation, quadratic equation. In quadratic equation, we have the sum of the roots and the product of the roots. Now they are asking the value of alpha square plus beta square, alpha cube plus beta cube, provided alpha plus beta and alpha into beta is known to us. Okay, alpha square plus beta square, we can write alpha plus beta whole square minus 2 alpha beta. Likewise, we can write all these values. Okay, after symmetrical roots, it comes Newton's formula. And Newton's formula is a very important topic as a JEE point of view nowadays. Okay, so in Newton's formula, what did we study? Newton's formula means, if I'll say that Sn is equals to alpha to the power n plus minus beta to the power n, where alpha and beta are the roots of the equation, then we can write Asn plus Bsn minus 1 plus Csn minus 2 equal to 0, and we consider the greatest n. Okay, after Newton's formula, we'll just move forward with the common roots. We know that in the quadratic equation, max to max we can have 2 roots. So there are 2 possibilities, when only one root is common and when both the roots are common. So when both the roots are common, then we say that equations are identical. So what can we say? That the corresponding coefficients will be proportional, like a1 by a2 equal to b1 by b2 equal to c1 by c2. Okay, if we have only one root common, method 1, if we have one root common, then if one equation is fully known to us, then we can solve that equation and we can find the roots, and those roots we can put into the other equation and we can find the value of the unknown. Method number 2, we can solve 2 equations to get the common root. Then method number 3, which is the popular one. What is the method 3? Suppose we have 2 equations, a1x square plus b1x plus c1 equal to 0, a2x square plus b2x plus c2 equals to 0. Then how we will write? First I'll take the first 2 columns. So first 2 column means I'll say a1 b2 minus a2 b1. Then I'll take the next 2 column. Next 2 column means I'll say b1 c2 minus b2 c1. After that the first and the third column is remaining, so that is equal to c1 a2 minus c2 a1 and whole square. So what is the condition? The condition is c1 a2 minus c2 a1 whole square equals to b1 c2 minus b2 c1 into a1 b2 minus a2 b1. Okay, after common roots we move forward with the analysis of graphs. So we know that there are two possibilities for the graph. If my a is positive, then we will have the upwards graph. If my a is negative, then we have the downwards graph. Now when we have upwards graph, in that also three possibilities are there based on the discriminant. So when discriminant is greater than 0, two distinct roots. Okay, so we'll get the first one. When discriminant is equal to 0, we'll get the graph like this. When discriminant is negative, then the graph will be like this. And likewise if my a is negative. Okay, after the graph analysis we have the range of the quadratic equation. So range of the quadratic equation, we know that if my graph is upwards, then we'll get a minimum and the maximum is not defined. So the range will be minus d by 4a to infinity. And if my a is negative, it means downwards parabola. In downwards parabola, maximum is defined but minimum not defined. So we'll say range will be minus infinity to minus d by 4a. Okay, that will be the range if nothing, no interval is given. If we have given a particular interval, then how to find the range? Then what we will do, suppose the interval is x belongs to x1 and x2. Suppose the interval is x from x1 x2, then what we will do, we will just calculate f of x. We will calculate f of x at 3 points. What will be those 3 points? 2 points will be the end points, like I will calculate f of x1, I will calculate f of x2. After that we will calculate minus b by 2a. If my minus b by 2a belongs to the interval, then we have to calculate f of minus b by 2a also. And after that, for all these three values, we will check out which one is the minimum and which one is the maximum. And corresponding to that, we will write down the range. And suppose if my minus b by 2a doesn't belong to the given interval, then we will check out the range from f of x1 and f of x2, like whatever the end point values are there, we will just check out those only. Okay, after that the last topic of this chapter is location of roots. In the location of roots, basically we have seen four most important like major categories. The category 1 is like the number k lies in between the roots. Number k lies in between the roots, it means the d will be greater than 0 and a into f of k will be less than 0. Then we have seen the second category. Second category means throw a number out of the roots. How to throw a number out of the roots? Condition 1 will be that d is greater than equal to 0, and then condition 2 will be a into f of k greater than 0. Okay, now the third category was outside the roots but in a particular direction. So first we have to send outside. So how to send outside? D greater than equal to 0 and a f of k greater than 0. How to send in a particular direction? By checking minus b by 2a. So if we have to send in the left side, then k will be less than minus b by 2a. If we have to send in the right side, then minus b by 2a will be less than k. It means my k will be greater than minus b by 2a. Then we have seen the fourth one, that exactly one root lies in between the interval k1 k2. So what we will say? We will say d is greater than 0 and f of k1 into f of k2 is less than 0. Thank you.